Right, good morning. Thank you for joining. I know I had to get up pretty early for this too. I have a morning spot because I can start your day off with some new stuff. So my name is Jeremy Brown, and this is my presentation on cloud device insecurity. And a gentleman earlier kind of asked the question because it does sound a little ambiguous, but I'll go into it deeper. But we are talking about NOS devices in this context, which are cloud enabled. So do things like sync your Facebook, sync your social media, sync your photos from your computer to the hard drive, essentially, because it's a NOS hard drive and it's got an interface, networking cable and stuff. But also can sync online to whatever company that manufactures. The vendor also sometimes provides those capabilities. So I'll get more into it, but let's begin. So quick run through the agenda, go through the introduction, introduce you to concepts a little more, then look at the targets. And the reason I asked earlier if any of you work for these companies is because these are the vendors whose devices I'll be talking about and showing you bugs in. And most of which are fixed. Some of them are a little iffy. So yeah, you'll see throughout. And then we'll go into disclosure, how I worked with the vendors or how they communicated with me, and conclusion and where we go from here. So again, my name is Jeremy Brown. I'm a currently independent researcher consultant. I used to work for Microsoft doing Windows security, some Xbox, Windows Phone security too. Started there at the Malware Protection Center, though, doing malware and other security research. Then I worked at Tenable for a bit, worked on Nessus, did a little bit of reverse engineering, worked on some plugins and looking at patches and stuff there. And I've been doing this for a while. So so what I'm not talking about, physical device hacking. I didn't take any firmware off chips here. I didn't open any of these devices physically. I just looked at them, the open box aspect of plugging in and what happens from there. No software that's bundled with the device. I didn't get any CDs that were included in the packages or anything like that. No client software, so it was mainly just the devices themselves and communicating with them and looking at the security of what they provide. And they weren't too good at security, or probably wouldn't be up here talking to you about it. But what I am talking about, hacking the device from the network. The LAN is the baseline, but your gateway, of course, controls how much internet access you give it. Some of these you can, like I said, the vendor can sync over the network and have a communication like that. But most of these, depending on how your gateway works, they can be accessible over the internet or they can be just on the LAN, depending on your configuration. All these that I'll be talking about are either remote vulnerabilities or some local roots. So they're pretty critical in that aspect. And everything I'll be talking about is by default. I didn't have to enable anything. I got the question before though, did you actually set up the devices? And yes, all the setups were completed and gone through. So when I did look at the devices, they were configured, but none of the settings were changed or anything like that. So it was a full default scenario. So why should you care? Why would I care? Well, I want to know how vulnerable my car is. There's been a lot of car hacking talks lately. All kinds of different blogs detailing routers with hard-coded creds, maybe implicitly, maybe explicitly. Excuse me. Crypto, you want to know about that, and privacy on your phone. All these things they really affect your life. So you kind of want to know what the security is before you plug them into your network, or have them on you at all times, like your phone. So I found this on Twitter a bit ago. Kevin Mitnick had tweeted about that he likes the MyCloud Western Digital, and coincidentally, that's one of the devices we'll be looking at today, and we'll see just how much the security is valued there. But I don't know if he was being sarcastic or what, but it seemed like he liked the MyCloud and he voted for its security. So a lot more people look at these. I've seen a few talks where you look at devices, but they're mostly just either borrowed ones or they're custom made or they're something like Arduino or something like that. But these ones, they do take a little small investment, up to $100, and then it may be in the few $100 range. So I did have to buy these. I didn't steal them. I did acquire them through legitimate means, of course, to look at the security. And you can't just, go to a website and start download the executable and start reversing, although there's nothing really wrong with that. So when I talk about this, I'm talking about Amazon. The website sells a lot of cloud devices, not talking about AWS, Amazon's cloud services. So I just wanted to show you that the huge number of vendors that are having these devices. If you just type in cloud and data storage, so it's pretty much looking for just NOS devices here. And there's a ton of different vendors that have these devices. And I'll show you today which ones I looked at, which I think are the 4 most prevalent, and the ones that I kind of sort about, like highest reviews, most reviewed, top rated, most bought, things like that. The ones that are out there, they're going to be most prevalent out there. But what is the personal cloud? When I talk about that, there's a few different kinds. Obviously AWS, and you have like Azure and stuff. It's a Microsoft Online Cloud. And you have NOS device clouds. That's the ones I'm talking about today. The ones that are NOSes, which are like network attached storage. So basically a hard drive with Ethernet jack. But these hard drives with Ethernet jacks have cloud functionality. And I'll go into more about that too. So PC NOS is just cloud features. So you can sync your social media, access your data from the internet, all the things you would expect with a cloud connected device. So now that you're familiar with what we're talking about, let's go into the targets. So there's 4 big players here. Like I said, these are the ones that I looked at. Western Digital MyCloud, the Akitio MyCloud, which was just, there's no space there. I don't know how they got away with that with copyright stuff, but yeah, that is a real name. The Seagate Central and Lacey Cloudbox. So from the marketing, you can read the quotes here. Your data is always safe and under control, provides safety and secure network storage. One of them even said from Lacey, ensures 100% security from data loss. That can be taken a few different ways. You could assume they're talking about hard drive failure, I guess. That's the only somewhat reasonable way they could be talking, even though that's kind of weird to say. But the marketing is definitely out there. They're marketing these as very secure devices. So let's look at the Central first. This is the model I looked at. I think it was all these models are either 2 terabyte, 4 terabyte, 6 terabyte, things like that. So they're pretty large storage. So as soon as you plug it in, 12 well-known open ports. You got FTP, SSH, you got a web server running, you got file sharing through Samba. So that many services open on a device like that you just plug in your network, that's a lot of attack surface. So first, when you SSH into the device, you can CU to root, and so your account already has root privileges. So there's no local attacks necessary at this point. So this is the distribution that the Central uses. It's Monte Vista Maxims, and it comes with this really strange haiku: maximum to minimum, agile yet stable, open yet secure. So they just plotted some random Linux distribution on the Central. And there's no root password. So you may be thinking, well, I can just log in as root with no password, right? Well, usually in the SHA daemon configuration, there's no passwordless root logins, which is kind of common sense for security. So you can't just log in as root like that. But it is passwordless root. So we did say there's an FTP server running here. But so even if we have full access through root through FTP server, kind of want a remote shell. I don't just want access to the file system. I want to get a remote shell. So it happens that the web server is running as root. So if we can log in via FTP, upload a PHP script, something that just executes commands on the system. If the web server is running as root, it's going to execute the commands as root. So simply FTP in, find the web root where all the web content's hosted, pop on a PHP shell, and now we have a remote root through FTP and the web server running as root. So there's total nonsensical security at this point. So I talked about some of these have social network integration. So the Central in particular has Facebook integration. So you can put on your credentials, it'll sync, it'll automatically upload your photos to Facebook and all that good stuff. So it keeps these credentials, or don't keep your credentials, it keeps a token in a first of all, it's world readable file on the file system. So anyone who has access to the device can get access to your token. And the token is something that once you log in, you get a token which kind of represents your session. And it has a expiration date and all that, but essentially if you're able to take someone else's token, you can log in and mimic that user for whatever period of time until it's set to expire. So again, if we look at the token file, it's just it's got Facebook and your name and token, and then it's got CAA and then your access token. So remember, we have remote root access to the file system and then the shell. But if we can abuse this further to steal the token file and get the token, we can even do things like, so this is a debug interface showing you what scopes you have. So there's different scopes with tokens. So you can look at a profile, you can look at the user's photos, videos, you can look at their friend list. So if we take that token and we just write a quick script that uses Facebook functionality to use the token and then ask for things like their friend list, then now not only do we have full compromise of the device, we have root access, remote root access, we also have access to their Facebook profile, and we can do things like get their friends, get their photos, get things like that. So a lot of times when you think of compromising device, you're like, okay, you just compromised this hard drive, that's fine, you have full access, what can you do? Well, if you put your Facebook credentials in there, I just own your Facebook account as well. And that's what it feels like. So there's a few other things too, like unprotected web resources. There's a lot of collateral left on these devices, just old passwords. You see like username. You guys can see that on, yeah, you can see it pretty well. Username is bhrath and 123, and there's just a lot of debug collateral and stuff left on the devices. And you can access it remotely through the web interface. There's no password on accessing this HTML file on the device. Again, on the file system, leaving just all kinds of usernames and passwords just littered in all kinds of different files and PHP files everywhere. And there's also a Seagate WSD daemon, and it runs on, I forget which port it runs on, but you can send just I was doing some SOAP fuzzing, so just sending some like malformed HTTP SOAP requests, and you can just trivially crash the daemon running that's interpreting these messages just by throwing some malformed SOAP messages at it. So I also want to look at the remote access, because this particular device had a feature where over the internet you can remotely dial into the device. So I thought that was interesting, and I wanted to see how that worked more. So it does this through a tap-in agent. So tap-in agent, they converted it looked like just a managed script. They converted to mono to run on Linux. And you can use this client, it's client server, and you can use the client to do the remote access. So I want to tell you a fail story, because I didn't get anything really useful on this, but it was interesting to look at. So in some cases, we can get a remote shell. So if you're able to guess the login credentials, which is one big step, but if you're able to do that, then you can browse around with root privileges on the file system in any ways. So administrator is equivalent to root when you're logging in remotely through the remote access feature. So that's kind of interesting. So one thing I want to look at, I wanted to, if I have read and write access to the file system through the remote access over the internet, I want to look at backdooring the startup script, because that's one of the things that if I can get the user to reboot, I can make it open up a command shell on a certain port, something like that. So I placed in like a line that says netcat and try to do a reverse shell on the device. So I was able to update that and waited for reboot. So they were pretty good on security on this thing, because they kind of fixed it where when I was able to upload it, it only uploaded it as my user. So I wasn't able to change the startup script that starts as root. I was only able to change it as my current user. So it's kind of strange where you log in, you're browsing with root privileges, but when you upload things, you still upload as a local user. So that was kind of strange. So I could get a remote shell just with or it's possible to get a remote shell, I believe, with the user, but I wasn't able to get a remote with this, but nonetheless interesting. So it also runs a media server called Django. And Django relies upon a secret key to do a lot of its cryptographic functions. So if you look at the line above, the comment says, make this unique and don't share it with anyone. Now this is relying on the file system of the device, and it ships to everyone. So, I don't think they generated this on the fresh install of every device either. So you can think of, once you have the secret key, you just compromised all these things that use secret key with Django. It uses for JSON object signing, all the password reset token functions, all the form security, things like that. I didn't check for sure to see if they generate this every time, but even if they don't, or even if they do, you're still able to steal this because you have the remote root. And now you not only compromise the device, you compromise everyone using the device, because everything that uses Django is now compromised. So if you find this device on your network, we talked about the remote root, quotaless storage, they just open up storage by default, let anyone write to it. Anytime you get user credentials, you get root, as we showed a second ago. And you can also steal the Facebook tokens and do interesting things with that. So let's go on to the next target, the Akitio MyCloud Mini. This is the device that I looked at. And as soon as we look at this device, we see that Telnet is open. So we're like, wow, it's going to be a short day now. And from the screenshot, you can also see they're using Fedora 12, which is, if you use Fedora, it's like on Fedora 22 right now. Super old. We can see Fedora 12 was published back in 2009, 2010, running a super old kernel version, all that good stuff. And when I looked at this one at the time, 21 was the latest. So that was that's definitely a sign of things to come. So, like the last one, we just sued and got root. This one's not so easy. We weren't able just to get root like that. But next thing I thought of was like, well, let's see if they have any nice sued binaries laying around. So binaries that are enabled to run with higher privileges, a lot of times it's root. So I looked around and I found that they had sued rooted the Python binary. No idea why you'd ever want to do that. I assume it was just some workaround for some bug they had, and they're like, oh, we need to run this as root, so let's just sudo root it. So that's pretty straightforward to get a local root from that. You just ask for it. You just say, okay, Python, you're running as root. Let me just write a script that says, set my UID to 0, set my GID to 0, and execute bash. And now we have a local root on the Akitio device. So another thing I looked at on this was updates. When I looked at the current version that shipped with the device was from 2014. It looks like July 2014. So I looked at the available updates and I saw that there was one, and this was a few months earlier this year. But the last update was in October 2014. But when I look, as you can see there beside current version, it says no update available. So even if they were security updates, they somehow screwed the update mechanism up. So I'm not even able to update if they do fix something. So just a total fail of security at that point. You can't even update to get the new features. So one thing that Akitio runs is this TR069. Some of you may have heard of it. There's a really good talk a while back about, it's called Too Many Cooks in the Kitchen, detailing TR069. It's a mess. It's a terribly insecure protocol. It's for provisioning, things like that. It runs on a ton of devices. A lot of IoT devices run this. And it's for, obviously all these protocols have good things at first. They're like, okay, we want to be able to provision all these devices and scale and all those things. But there's absolutely no security in the protocol. And it runs it as the NOS-TR server. So I run the server in debug mode just so I can look at the best messages being passed back and forth. And it's a lot of interesting information. They're just passing SOAP messages back and forth with like the manufacturer, all the ID, just a ton of sensitive data passing back and forth between the client server, and the server is actually able to do a lot of things to the device as well. So you could see this is, and I don't think any of this is over SSL. So you can see a man in the middle would be pretty devastating here. So like I said, the work's already been done to look at TR069. I highly recommend the Too Many Cooks talk. It's super interesting, all the things that are bad about the protocol. And but the good news is, once you root the device, you can turn it off. You can just kill the process, and you don't have to worry about it anymore. But it's kind of one of those jailbreak things where like you need to root the device to make it more secure or less secure in jailbreak, but different story. And another interesting thing I found here was the professional coders they had writing the software for the device. This is one of the Python files I looked at, and it literally they didn't even take the time to remove the guy's name or say, this property of a Kidio or copyright and all that. They just left on his full name and his personal email address on the Python file. So you see what kind of professional software you're getting when you buy these devices. So it kind of looks like this at this point. A lot of cloud, a lot of modern, not very security. So the biggest thing about this device that I found, the biggest security issue I found, was when I was looking at the web root, I found a couple of files in it called test.html and test.javascript. Those sound really interesting. So if I just go to test.html, I get a command prompt. And that is kind of a dream if you're a security researcher. If you're looking at this, you get a command, like you're just giving, this is not usually accessible. This is probably like collateral left on the device. And now it's asking you what you want to do. So at that point, I'm just like, well, what can I do? So I type in help, gives me a bunch of different commands. I can test the LEDs, I can mess with the buttons, set the clock, look at the USB capacity. But the most interesting one was key. And key is described as get secret key. Very interesting. We type in key, it returns us this alphanumeric value. It's probably 16 bytes long, which is secret key. But it sounds great, but what does it do at this point? But I want to look at where it got secret key too. And it's embedded in the flash, the flash drive that's on the flash memory on the device. So it opens up dev empty block 1, and at a very particular offset, it gets the secret key. So you kind of imagine that I don't think they shipped a different secret key in each flash device for every device, because that would just be terribly expensive to do. So we can assume at this point it's pretty much universal through all the devices. And all you need to do to get it is type in key with the command prompt. So I really want to know what it's used for, because I spent a lot of time looking at the device saying, what is secret key used for? But I thought, why don't I just ask the vendor? When I tell them about all these bugs, be like, hey, I found a way to leak your secret key. What does it do? So I asked them, and they said secret key is used for remote assistance service. I don't remember looking at that feature on the device. What is the remote assistance service? And it says you can disable that in the preferences. Okay, so I looked at preferences. There's nothing there. There's nothing about remote assistance service. So fast forward, a very long, drawn out thread with them, because that's how I communicated. It was like this support thread. It's ridiculously bad. But they eventually said, we're not at liberty to disclose any more details about how we use secret key. You really want me, I really want to know what this does now. It's really getting me interested in. Sorry, I forgot to mention earlier, I only spent a few days on each of these devices, so I had to move on to the next one. And I wanted to come back to it later, but that didn't end up working out. But if you look at if you have Wi-Fi and stuff, you can look at the Pastebin article, which has got the full conversation. It's ridiculously back and forth, well, what does this do? And they're like, oh, it's for this. And I'm like, well, I checked that and it's not there. And they just keep giving me bull crap the whole time. But long story short, we still don't know what secret key does, but we know it's very important according to them. So for this device, just look for test.html and you get a command prompt. It's pretty awesome. User access is root access. They sued root the Python binary. Still kind of unbelievable. And TR69 prevalent on this device. If you own one, please turn it off. You don't need it. So the next one, probably the most popular one here, the Western Digital MyCloud. They actually have commercials. This is the overclouded commercial. Talks about the device and how it's so awesome. And I screenshotted part of this because this was like when they talk about security, they're like, this is the cloud hacker and this is how we protect you. The typical 80s European looking over the shoulder, because that's how you hack, right? So they're actually marketing security in the commercial, I assume on TV at some point. So the thing with this device that struck me as the most interesting was the auto authentication. Now they don't call it this, but this is what I dubbed it because that's exactly what it is. You're always logged in as administrator by default. You have to jump through a lot of hoops to add a password to this device. Like I literally had to look up the documentation to figure out how to add a password. So you can see it switching. You can see how they implemented it because you'll go to the login. You'll type in HTTPS or HTTP, the IP address, and you'll go to the page, and you can see it flipping through, and it's like just logging you in with whatever credentials. So it's auto authentication. So by default, you have full access to the web UI, full administrator access. What can you do from here? Let's see. But first, let's talk about T1Q2. There's a media server that also has no authentication by default. So the theme with this device is more, there's just no authentication. Like I said, you have to jump through a lot of hoops to turn it on. It is there at some point, but by default, it's wide open. So if you look, I did like a strings on the T1Q server and I looked for all these RPC functions, and you can control the device, do whatever you want, restart it, rebuild. All these different commands, 99 different commands, probably 100 different things you can do to the T1Q server with no password. So one trick I tried here, briefly mentioned, was there was a feature for the T1Q server to back up the metadata. So I wasn't able to control the contents, and I couldn't put it anywhere else, but I was able to create a file on the device like this. So this is actually an ongoing bug with the T1Q server. Not very interesting, but because I didn't really exploit anything, but still something that shouldn't really happen. So another thing I tried with the T1Q server was tried to inject some meta characters into the way that, because the way it works is you drop all these media files into a folder, and you point T1Q to that folder that you want to build a database of. So you can just play them in your playlist, and you don't have to list the data every time because that would be super inefficient. So when it builds this, it passes these as shell characters to build all these things out natively with the Linux shell. So what I did was I was trying to insert some meta characters, drop it in the public, because if this worked, it would be it'd be like beyond by default. It'd be like you drop this in a public folder, you cause a rebuild through the T1Q commands that we just listed that are unauthenticated, and you could get a remote like that. So that was a super great attack vector. But it ended up not working. They actually filtered this. I can just imagine it has some internal pen test at some point, and they're like, you guys really shouldn't do this. You should really fix this. I guarantee they didn't do this by default. This was something that you would have to look for and fix. But they did fix this, and that is not an attack. So one thing I looked at, since we have the auto authentication and full access to the web UI, I wanted to see if I could just brick the device, first of all, because I can restore it. well, hopefully with this device. I don't know how resilient it is, but my first thought was, let me just see if I can brick it just by simply uploading a random firmware image. And when I tried the random firmware image, I literally just tried because I figured out I'd just tried a random file. Any file on my computer, doesn't matter what it was. So it told me error, invalid file type, please select the .deb file. So, okay, now I see the package manager is using deb files. So I download a random deb file and say, okay, let me see if I can do that. So this is the process of basically the process of elimination, seeing what I can do and letting it tell me these really descriptive error messages to see, what I'm confined to actually do for the uploading of the firmware. So now it says invalid firmware package. So I know something's got to be different about these packages. And we know there's some sanity checks, of course. So I was like, forget all that. I don't even want to brick the device anymore. I want to see if I can get a remote. I want to see if I can inject any characters. So I tried the shell meta characters again. And boom, when I look at the processes on the device, I can see that I executed the ID command in the middle of resolving the file name. Okay, so I have a command injection there. But even more, if I do sudo ID, the user that the web server is executing this command as has sudo privileges. So if I just do sudo, it executes ID as root and tells me I'm running as root. So great, now I have command execution as root. And how many times does it do that? It calls the API execute runtime 283 times. So theoretically, you have 283 chances to inject commands here, as root too, because it does sudo on every one of these. So through the web UI, we just got a command injection as root, or as user, whichever one you prefer. So this does this in device.php. You can see also that we can inject meta characters in device.php just using the description. So there's just command injection everywhere. This is another example of the 283 times it uses it. Another attack vector is through device.php, just by simply telling it what you want. And there was some security comments in some of these files too. So like one of these requires admin authentication requests allowed in LAN only. So there's a huge disconnect between I can just imagine there's two teams working in a software company before. There's a ton of different teams working on usually specific features. And they can be disambiguated throughout, but I can just imagine there's two teams one working on the main code for the UI, and another team working on another feature, maybe the auto authentication feature. And this one, definitely goodwill. They're saying, okay, we have to have admin authentication, but the auto authentication feature comes along and says, oh, but we want this to be really easy for everyone to use. So we're just going to bypass that authentication. So if you read the comments, you're thinking, oh, I have to be admin to do this, or I have to be on the LAN. But none of that's really enforced because of the new feature so you can see the disconnect between the two teams, one wanting to do one thing with security and another bypassing it. So, pen tester's cheat sheet, you have infinity T-wonky commands to try there. Plenty of remote root options in the web UI. The default root password is welcome, by the way, if you want to use SSH and turn it on. And auto authentication is a huge killer for this device. So our final target, the Lacy Cloud Box. It's actually this one right here. I have it on stage, and I'll tell you a little bit why later. Stick around to the end. But this device was pretty interesting. Seagate acquired Lacy recently, well, a few years ago. So they're kind of like the controlling vested interest in Lacy at this point. So I don't know if they're going to combine like the Seagate Central with the Lacy Cloud Box. There's got to be something that's going to happen in the future, I would say. But Seagate owns Lacy. So if we start the adding user accounts, obviously from security perspective, password optional, not very good. But I looked at the root password. I was able to root this device in other ways. I looked at the root password and it looks pretty random. So there's not really a big shot to do anything with it there. But as far as user accounts, we don't have to create a password if you don't want to. So the way I was able to elevate privileges here, it runs a NOS backup script, and it's available in the web UI with any user, like the user that's specified here. So we're able to, this is the disassembly of it, and we can see that it's calling core utils. So core utils copy is just a local Linux, basically the copy command from the core utils package. So we can see that it's taking shell commands here. So if we go to the dashboard and go to backup and just create a job, name the job, test, again, inject some meta characters, and click start, we can execute commands as root on the device. So it doesn't just do this with regular user privileges, it executes the commands through the web UI as root, recurring theme, and now we can execute whatever commands we want from there. So we escalated privileges from the web UI to root, and there's a bunch of other commands that it calls as well from the web interface, so probably some other bonus bugs there as well. It also runs a media server called, well, it's Firefly now, but it used to be, the common name is MT Dap Daemon. default admin password explicitly runs as root. I don't think this is by default. I think they literally changed the run as to root. So again, not very defense in depth if you're familiar with that concept. So the most interesting thing about this device was, suppose, I'll be theoretical, but this actually happened. Suppose we found plaintext credentials for the device's update server on the file system. So we look on the file system, we see a configuration file, and it's got a username, password, server, everything that uses to log in. And this is also documented online as well through this one blog. So say we have that, we have login to the server. Now if we just emulate, and we're doing nothing other than CloudBox does, it just logs into the server FTP, checks if there is a new version, downloads it if it is, installs it, blah, blah, blah. So if we have that login to the server, now suppose we see the permissions on the update server were pretty interesting. What if they were, read write across the board? So we're supposing on the update server for all the devices, the official update server, if they were read, write, execute, or read and write for everyone. You kind of imagine from there how to visualize an exploit. You have clear text upgrades, so you take those credentials, you log in, and also there's things about some design flaws. If it is checking the hashes for the files, suppose there's a design flaw there to bypass the hashing check. And of course, the misconfiguration of being readable and writable by any user is a huge deal. So at that point, it's pretty clear if all those things go smoothly. It's a unicorn exploit. One bug to rule all the devices. And the way I looked at it was kind of like this. You extract the file system, insert whatever code you want. So we're talking about backdooring the firmware. Repackage it and update it to a later version. So if we're able to place it back on the server because we have read-write privileges, anybody who checks for a new version is going to say, oh, there's a new version. Download that, apply it to the device, and from there you just backdoored every device that updates at this point. So that looked really interesting. So I submitted to Lacey, and Lacey's response was they supposedly investigated, determined the FTP permissions were actually correct, but the FTP server they were using was like Gene 6 or something, and it was displaying Unix style permissions, read, write, rewrite, rewrite, but they actually sent me a screenshot showing that on the server that was running on Windows, it was not read, write, it was administrator only. So very confusing though, because when you first look at it remotely, you really don't know, you really can't see, you can't tell what the permissions are. You just assume those are correct. But the unicorn bug ended up turning into, which is great for end users, all your devices aren't backdoored anymore, which I originally might have thought. They're actually safe because the permissions, supposedly, what I was told and showed a screenshot of, which I can pretty much believe, I guess, that it was actually okay permissions and nothing to worry about. So, like I said, it was just hard to verify that because, I don't own the update server. I don't want to try to upload anything because probably illegal, frowned upon at least. So I can't really test a backup server like that. And even if I could, I don't know the actual permissions that they have on their server. So it's really hard to test that. That was from my side, it was a super interesting case where you have a bug and you can't really test it because it is like on someone else's environment, on their machine, on their infrastructure. So even if you can replicate everything, even if you can replicate the FTP server and all that, you still don't know for sure what the actual permissions are. So, but they did have some pretty weak permission checks. They kept the SHA-1 hash inside the file. So there's two files. One, which is the image of the device, and another which keeps the hashes of the image of the device. So if you're able to just insert a new hash in the file, all those are changeable. So the way it was checking, it was checking a really bad way. So very bad security from the integrity checks wise. So after reporting all this, they came out with a security update and had a major security fix for NOS OS. I don't know if there's anything related to my work. Could have been, could have not been. But that was awful coincidental that after they were aware of all this stuff, they fixed a lot of issues. So reaching out wise, for these devices, for these vendors, there's been a lot of blog posts, a lot of, there's one public exploit that got released, I think, for Western Digital, affecting a bunch of devices that they just literally would not work with and would not patch it, so he released it. I mean, sounds reasonable. There's no security, no email addresses for any of these vendors. Everything is just open a support ticket. Open a support ticket, see where it goes from there. I never saw an advisory, and this could have changed in the last month or so, but the last time I checked, I've never seen a public advisory for these things. It's always just in the updates, there's release notes for like, oh, we had a little security fix, and it's probably like a huge security fix, but constantly downplayed, no real security work coming out of the vendors. So let's look at the disclosure, because I just showed you a ton of bugs, and you're probably interested in how they handled them. And my friend Christopher Columbus is going to show us how to do this. So Seagate reported back in January. Really weird response at first. They were telling me, I sent them all the information. They're like, hey, these devices weren't affected by shell shock. You don't need to worry. It had nothing to do with shell shock, but that was like their default response to any security inquiry. Eventually got them fixed. I hope all of them. They released like this kind of weird system where you have to type in your serial number, and it's not really public and all these things. But they had supposedly released fixes for this back in May. The KDO was actually pretty fast, but just the weird process of the secret key and not written. I mean, honestly, I don't know if I can say directly lying, but it was pretty evasive tactics for answering my questions. But they eventually fixed all these bugs, so that was a super quick turnaround for them. Western Digital reported back in January, no response the whole time. Escalated to CERT, tried to ask them for help. They were helpful sometimes, but they couldn't get anything from them either. So I publicly disclosed all this back in almost June, a couple months ago. And what's interesting about Western Digital and their support forums, I was asking like, hey, is there anybody handle security on here? Can you guys help me? I want to report some bugs. A bunch of different times. And even the consumers of Western Digital's cloud devices, they were just so, I don't know if they're being sarcastic, they were just funny, really. They were just like, I look forward to your disclosure. I hope you disclose all these bugs. These guys suck. They never help us with anything. That's literally their responses. I was like, wow, you guys have been putting up with stuff for a while, sounds like. And then with Lacey, reported just a few months ago, of course, they responded with their analysis. They were unable to repo the command injection. Honestly, I think they fixed it. I think they had fixed it at some point, but I don't know for sure. I also described the corner case mitigation for the unicorn bug, and then they were telling me about the permissions. They showed me a screenshot. I guess I can believe that. But still, it was a super interesting issue to even think about, because that is not a typical exploit. And then today, share my results with you guys for Lacey. So, on the conclusion, is it really all doom and gloom? Well, yeah, it is. It's very bad. There's not really a clear path forward either. There's no security in these devices. Combined, if you look at Microsoft, Apple, even Apple, Google, all these software companies, or whatever they want to be called now, they're doing the cloud vendors have taken a huge step back compared to any of the processes the other big guys have, which they shouldn't be as good, but they got to be better than this. Security expectation: if you plug any of these devices into your network, assume it is compromised. Don't have any expectations for security, because they are none. A couple of solutions I was thinking of: you could root these devices, which I just showed you how to root like 3 of them, and just install FreeNOS or something like that. I know a lot of people tend to do that, but I'm like, if you're going to install FreeNOS, why don't you just take a hard drive and put a network card on it, or something like that, instead of spending the money for the software, I guess you would, and all the cloud features. So you could do that, or you just don't buy the devices. Like I said, they're very bad. If you want security, talk to the vendors. They kind of only have help desk. There's no emails. Like I think they've literally eradicated that strategy whatsoever. They just don't do emails. You have to like get a person to talk to on email. There's no public emails for this. I actually spent a lot of time on LinkedIn looking for people who work for the company to get their personal email addresses to then talk to them about the issues, because that's the only way you can get anywhere with them. But it takes a lot of time. I spent so much time, I feel like I wasted so much time hunting people down to look for answers. So as of today, like the recurring theme, don't trust cloud devices. They're not ready for any kind of security. And honestly, I think the cloud in general, there's some exceptions. It's just a marketing lie. It's fine for non-secrets, but not okay for secrets, because they're probably not going to be secret anymore. And questions. And before I go to questions, I mentioned earlier I have this device, and for the best question, I will give it to you. It is basically brand new. I just looked at it for security. It's not backdoored, nothing like that. I literally did my analysis, reset it, fresh, ready to go. If nothing else, it's a brick or a 6 terabyte hard drive, whichever one you prefer. So ask me some questions. I'll have to determine what the best one is. And we have the first one back there. Site cell. Oh, okay, that one. Okay. I've heard of the company. I didn't look at any of their devices though. Yeah, so I'm sorry, I didn't look. I know they are a pretty popular company for devices. I didn't know they do cloud NASAs though. So, okay, interesting. Gotcha. Okay, good. Yes. Yeah, you wouldn't use the serial number to look for devices like that. The serial number I just put for, well, I don't even think I put the actual serial number on the screenshots. I think that was just the model number to look at it. They probably looked like serial numbers at some point. But if you were to find them on the web, if you were looking for them, if they're exposed to the internet, you could look for their web interface. I'm sure if you just do like an Nmap, there's probably some Nmap script you can do to search like over a bunch of IP addresses for Western Digital or MyCloud or Akidio, stuff like that. And you could probably find a lot of these devices. And the bugs that are in these are probably shared throughout a lot of the other devices as well. So it'd be pretty easy to scan for. I would just look for just strings like the device name or the device model, something like that, across a large IP range. Yes. Yeah, so with Western Digital, I didn't look at their remote services on that. I looked at, what was it, Seagate. I looked at the remote one on that one. Yeah, that would be interesting to look at. I didn't look at that area on the Western Digital in particular, but that would be definitely a huge attack surface if you're able to log in remotely, just like Seagate. I imagine it's a similar system. If you're logging remotely, you can control the device and stuff like that. So that would be a key point of attack for if you're going after the devices, if you want a clear shot from the provider to the device. Yeah, good question. Any other questions? Yes.
I've got users that have they've enjoyed using these devices in the past, and I've always looked at them thinking their personal device, their personal style for storage, like don't worry too much about it. They're not enterprising in a sense, but now looking at it after your presentation, I think they're pretty poor on a lot of things. Had a mission of you got to give somebody 4 terabytes, it doesn't want to be on a fan or something. Would you say you whip up a DIY FreeNAS, like on a desktop or something, and then say there's your NAS go with something like this, then root it, and then put FreeNAS on there? Like, what would you go through, like, now knowing that I need to get a budget NAS going for some user? Or would you say, you know what, there's no such thing as a budget NAS anymore? Like,
I think that one thing I've used before was just literally just buying an external hard drive and then plugging it into, like, I have a Windows computer or Linux or whatever, and just sharing it from there. If they're just looking for personal storage, that's, to me, you're relying on, like, the Windows or Linux access controls, which are much more vetted and much more secure than these things. So, I mean, that would be my solution. I did that before. Because you see a lot of people at work too. You mentioned they weren't really for enterprise, but there's kind of these situations where, you're at work, you're like, oh, I need a bunch of storage. You ask the admin to buy you some hard drive, and she does, or some scenario like that. So they kind of turn into this thing where if you're red teaming a software company, I guarantee you're going to find a ton of just external hard drives or shares out there. Because of that. And I don't know if they're going to be using Western Digital or any of the cloud devices, or they may just be sharing the hard drives like I mentioned. But that's a scenario where it might be relevant. But like my advice, I would just share a hard drive. I wouldn't. But then you don't get the cloud features and things like that. I don't know. I guess I would just live without the cloud features for me, because there's no really good security solution at this point for that.
You think, like, you say, like, I need 6 terabytes of NAS. If the box says it has cloud features, do you think that's a red flag, like, back away from that?
At this point, I think it is, because, like I said, the four biggest players that I found, I didn't look at Zyxel, I actually should look at them, but the 4 that I looked at, they were just 2015. You don't want to use them. They're not ready for security. I think if I had to recommend, just if you're just setting up a FreeNAS may be a good one, because at least they're open source. At least like when bugs get publicized, they're going to get fixed pretty quick. I know there was actually a couple of remote roots in FreeNAS the last few years, but they were all fixed, and you didn't have to wait 6 months for them to never respond to you, stuff like that. So if I had to go into the NAS system, I'd probably use FreeNAS. But for me personally, the most secure, just plug it into your computer and share it, and configure the permissions securely when you share it, of course. Oh, good question. Back here? Sure. Yeah, they'd be in the same realm, I think, because I don't know if this one does. Some of them I looked at actually have a USB port on the side, so you can plug in even more storage. There's like 6 terabytes. I don't know why you'd ever want to do that, but some of them do have features like that. So you could probably, if they have USB ports, you could probably even chain the loop of insecurity, chain one of the cloud devices with a router. And if you've been paying attention on the internet the last few weeks, you've seen all these routers with all these crazy backdoors and things like that. There's been a lot recently and throughout the years. So I guess the router vendors have had a lot more time to see the effects of the insecurities they have in their devices, and they've been working with the security community more often. Still not as much. So I guess the cloud vendors are kind of like lagging behind like that. Because you see Western Digital, you see Seagate, everyone's probably been using their hard drives for years. I've been using it since I was a kid, putting a new Seagate drive in my box. So now they're transitioning to cloud devices, which is a completely different concept than like physical storage, of course. But to answer your question, I would assume the security is marginally better, but not much. Yeah. Sorry, does anyone else have a question? Yes. No, so all the ones I looked at before I didn't see any of them. None of them were encrypted. The file system none of them were encrypted, as far as I know. So yeah, that's another good point. Yeah, none of them. Well, I guess you're replying on physical security at that point, because they're not really portable anyways. But yeah, none of them had encryption on the file system. Yeah. That's true. Yeah, depending on the environment, there could be some vulnerability there. Good question. Yes. I think all the ones I looked at were just single, none of them were even SSD. They were just either IDE or SCSI, I imagine, with the USB interface, of course. Yeah. All right. Any other questions? I'll make a final analysis. I'll have some. Go ahead. Probo? Drobo. It's not ringing a bell. Drobo. I don't know. I didn't look into those. Drobo. I have to. It sounds interesting though. All right. Man, good questions. Deliberation. I don't know. Maybe. I think I'm gonna go with you. You asked a couple. You were kind of at the end. You were kind of falling off, but I think you asked enough good ones that were good. So yes, whenever you're ready, you can get your cloud device. Thank you very much for coming, and I'm glad I could share this stuff with you.
Okay, welcome everybody to the last day of SaintCon.